This is a short video on how to convert a recurring decimal into a fraction. Let's take the number 0.5 recurring. Our first step is to give this number a name. We're going to call it x. Now notice that our recurring decimal has only one digit that is repeating, and that this repeating part starts immediately to the right of the decimal point. Our next step is to multiply by 10 to give us 10x equals 5.5 recurring. Now the reason we've done this is because what we need for this procedure to work is we need two numbers which are identical after the decimal point. And that's what we have now. And now that we have that, we can take one number away from the other, and that will leave us with just an integer, won't it? So let's take away x from 10x, and that's going to give us 9x equals just 5. So by taking one number away from the other, because they are identical after the decimal point, it leaves us with just an integer. And we can now just solve that by dividing through by 9 to give us x equals 5 over 9. Let's look at another example now where we've got two digits that are recurring. So let's take 0.17 recurring. So it's the 1 and 7 that are repeating, but again notice that the repeating part starts immediately to the right of the decimal point. Again, we're going to give it a name, but this time we're not going to multiply by 10, because multiplying by 10 is not going to help us. Remember, what we need is two numbers that are identical to the right of the decimal point. What we need to do is actually multiply by 100 to get that. So we're going to multiply by 100, so it's 100x equals 17.17 recurring. And now we've got what we need. We've got two numbers that are identical after the decimal point, and we can take one away from the other. So let's take x away from 100x to give us 99x equals 17. And again, we're just going to solve that by dividing 3 by 99 to give us x equals 17 over 99. So we're going to look at one more example now, but in this case the repeating digits are not going to start immediately after the decimal point. So let's choose 0.423 recurring, where the 2, 3 are repeating but the 4 is not. And again, we're going to give it the name x. And we've got an extra step in this case. What we need to do is to move the repeating part up to the decimal point. And if you think about it, or try and think through the example that we're doing, you'll understand why that is. So let's do that. Let's move the repeating part up to the decimal point. So we're going to end up with 10x equals 4.23 recurring. Okay. And you can see, well, we've done what we aim to do. We've moved the repeated part up to the decimal point, but we haven't got two numbers now which are identical after the decimal point. What we need is another number, and to get another number, what we can do is multiply this 10x number by 100. We need to multiply 100 because we need to move 2 digits along. So we multiply 10x by 100, and that's going to give us 1000x equals 423.23 recurring. And now you can see that we have the two numbers that we need. We have two numbers which are identical after the decimal point, to the right of the decimal point. And we can take one number away from the other. So we're going to take the 10x away from the 1000x. And that's going to give us 990x equals, well, 423 take away the 4 is going to be 419. And again, we just solve by divided through by 990. So it's x equals 419 over 990. Okay, so we have 3 examples there for you to look at. Look at them again if you need to. Just remember that you need to focus on having 2 numbers which are identical after the decimal point, which you've generated by multiplying your original number by powers of 10.